In this last section, we'll discuss some application of propositions for puzzles. And the key takeaway isn't so much the puzzles, and maybe you enjoy puzzles, and that's fun, but the thinking is what's most important, is how can we develop a systematic way of thinking. So in this first puzzle, we are on an island, and there are two different types of inhabitants on this island: knights who always tell the truth, and knaves who always lie. And then we come across these two inhabitants, A and B. And we want to figure out what A and B are based on what they tell us. So A says B is a knight, and B says the two of us are opposites. And we want to figure out, how can we determine if they're knights or knaves based on what they said, so that their statements are consistent with whether they are knights or knaves. Okay, so there's 4 possibilities. So they can both be knights, or A can be a knight and B can be a knave, or A can be a knave and B can be a knight, or they can both be knaves. And we want to check, based on whether they are knights or knaves, if what they're saying is consistent with that. So the first thing is, if we assume that A is a knight and A says B is a knight, then if B is a knight and says the two of us are opposites, that's not possible, because both of them would be knights, and knights don't lie, so that would be a lie. So we have to eliminate that they're both knights. Okay, now let's consider if A is a knight and says B is a knight. Well, if A is a knight and says that B is a knight, then since the knight doesn't lie, B couldn't be a knave simultaneously. And what's more is that if B were a knave, B wouldn't tell the truth and say that we're both opposites. So we have to eliminate that also, that B is a knave telling the truth, saying that they're both opposites. Okay, now let's look at the third possibility. We have A is a knave saying that B is a knight. Well, if A is a knave and B is really a knight, well, that would be a problem, because that would mean that the knave is actually telling the truth, that B is really a knight, and the knight would really be telling the truth when the knight said the two of us are opposite. But the problem with this is that the knave would be telling the truth when the knave always has to lie. So that's a problem. So now we're left with the only possibility, which we haven't eliminated, is that they're both knaves. So let's think about this. If A is a knave and says B is a knight, the knave A would have to be lying. So that would mean B is a knave. And then if B is actually a knave and says the two of us are opposites, B, the knave, would be lying, because both A and B would both be knaves. So this is an example of how we can use logic to eliminate the statements that were not consistent with whether A and B were knights or knaves. So some of what our exercise that we were doing is we were actually checking if A had this role and also the statement that A was saying. One helpful exercise to help think through this might be to write what statements would have to be consistent in each scenario. So just to give an example, so if A is a knight, so we have A is a knight, and tells the truth, so B is a knight, and B says they're opposites, you'll notice that we can tell that this was not consistent, because if B is a knight and tells the truth and says they're opposites when they're both knights, that would be a lie. So we can tell, okay, this last statement could not be consistent with A being a knight and B being a knight. So that might be a good example of going through this chart and writing the statements that would have to be consistent in order for this scenario to be true. So now when we think about the scenario where we determine that they're both knaves, we can say, well, A is a knave and lies and says B is a knight, which implies that B is a knave, and B lies and says they're opposite, and B is a knave. From that, we can see that all of those statements are true simultaneously. So when you're thinking of a puzzle, you want to enumerate the possibilities and then start enumerating the statements that would have to be true simultaneously in order for the selection to be true. So that's checking that all of these statements would have to be true simultaneously. Now, let's look at one final puzzle. And this is a tourist problem, and this is a pretty well-known riddle. So we're tourists, and we come to a junction, and we're looking for the city. Now, the city may be to the left or to the right, and there's a local who is at the junction, but we don't know if the person is honest or not, and they can only tell us yes or no. So we want to think of what question we can ask this local, where if the local says yes, we'll go to the left, and if the local says no, we'll go to the right. And we want to be able to go to the city regardless of whether the local lies to us or not. So now we want to think about what question would we ask this local. So the first thing is, let's just try one question. So if we ask, the question was, is the city to the left? Now, if the local was honest, he or she would say yes, and we'd go to the left. But if the local was dishonest, then he or she would say no, and we'd go to the right. So just asking, is the city to the left, won't help us, because we could be misguided. So we have to think a little bit more about what question we can ask, whether the local is honest with us or not. We need to get the local to say yes if we need to go to the left to the city, and no if we should go to the right. So now let's try another question. So now the question that the tourist is going to ask the local is, if I were to ask you whether the city is to the left, would you answer yes? Okay, let's see what the honest local would do. Okay, so the honest local would, if we were to ask the honest local if the city is to the left, the honest local would say yes, the city is to the left, and the honest local would answer yes. But what would the dishonest local do? The dishonest local would, if asked is the city to the left, would answer no. But if we were to ask the local what the local would tell us, if the local would tell us no, when we ask, would you answer yes, the local would then have to answer yes. Because it would say no, but since the local would lie, they would just negate the answer. So if the city was actually to the left, both the honest local and the dishonest local would answer yes. And if it weren't to the left, the honest local would just say no. The dishonest local would say yes, but then we're asking, would you answer yes? And then the dishonest local will say no. So this is a way in order to get both the honest local and the dishonest local to give us the same response to the question. So if the city is actually to the left, both would answer yes. But if it's not, they would both answer no. Okay, let's just recap. So as we had noticed before, if we just ask the local, is the city to the left or to the right, the honest local will tell us yes if the city is to the left and no if the city is to the right. But the dishonest local will flip those answers. So if the city is to the left, the dishonest local would say no, and if the city was to the right, they would say yes. So now that's why we asked, if I were to ask you whether the city is to the left, would you answer yes? So the honest local would say yes if the city is to the left, and if the city was to the right, would say no. But if we ask the dishonest local, is the city to the left, the dishonest local would say no, but would you answer yes? They would flip it. So they would say yes. And the dishonest local, if we asked them was to the right, they would say yes. And we would flip that, and you'd get, would you answer yes, and say no. So using the asking what the local would answer is what gets both the honest and the dishonest local to give the same answer to the question.